Hey everyone, so we are going to continue what we started yesterday. I've obviously changed settings. I'm in a completely different spot now. I've changed cameras. I've got a slightly better quality camera. Hopefully I've actually ordered one that does full HD. This one does 720p, but I'm also using capture software that both captures audio, video, and also does a capture of my lovely face. So today we are going to continue with the PowerPoint that we started in class. We left off discussing the three terms internet, intranet, and extranet. So we're going to move on from there. Okay, so here is a screenshot that includes a WAN connection. If you look here, you've got your WAN link, and then you've got a couple of LANs. The whole thing is an internetwork, if you want to look at this as an internetwork. It becomes an extranet because there is access from the public internet to resources. Now, as far as what would be restricted and what wouldn't, that becomes a matter of configuration. So if you configure settings on this router here for the purposes of access to resource, then that would make this an extranet. If there is no access to resources from the outside, then it is an intranet. Okay. Alright, let's continue on here. So, packets and frames. These are two additional terms that are important. When data is transferred on a network, it is done, in most cases, particularly in the case of LAN networking, it is done in bursts of 1500 bytes. For a number of different reasons. Obviously, a pause between bursts allows the computers that are transferring the data to process what's happening. The receiving computer to process received data, and allows other computers as well to transfer data during those pauses. So a large file being transferred over a network would take up a ton of network resources if you had to transfer the entire thing from point A to point B. Not to mention, think about how effective the internet would be if we had large sectors of the internet being taken up with, a gigabyte file being transferred. That would take a long time with the speed of the internet. So that's a limiting factor when you start to expand out the size of your network. It becomes more difficult to get large amounts of data from point A to point B without breaking it up. It also allows the receiving computer to receive data from other computers at the same time. So a receiving computer can be receiving multiple chunks of data from different sources at a given time. So not at the exact same moment, obviously, but you can be receiving data and sending data at the same time. So the breaking up of data into 1500 byte chunks makes a lot of different things work at the same time. So it allows mostly for multitasking, I would say. And then the other big factor involved here is that if errors occur in a single chunk of data, 1500 bytes is a lot easier to retransmit than an entire, say you're transferring a 1 gigabyte file. If one portion of that file becomes corrupted in the transfer, you would have to retransfer the entire gigabyte file, where by breaking it up into smaller chunks, only that one chunk that gets corrupted along the way would have to be retransmitted. Okay. Alright, so chunks of data sent across the network are usually called packets or frames, with packets being the more well-known term. The terms are not completely separated. Well, they have two different meanings, but every frame includes a packet, but not every packet has a frame just yet. So you'll see sort of the distinction there. But a packet is defined pretty well as a chunk of data with a source and destination IP address added to it. So if I could quickly do a little illustration to demonstrate. Oops. Hold on 1 second. I'd rather use a marker so that you can see it. And a sheet of scratch paper here. So if you have a chunk of data like so, you add, at the front end, you add an IP header. Okay? And now it is known as a packet. So that IP header is source and destination IP address. Okay? This is specifically referring to the TCP/IP, the IP portion of the TCP/IP protocol. And actually, this also includes the TCP portion. We're not going to delve into that today, but this would be sort of the IP portion of that protocol stack. Okay, so in the U.S. mail analogy, you can look at a packet as an envelope that has the zip code added, but not the street address just yet. Okay, so we've added the zip code if you're looking at a physical mail analogy. Okay, now a frame is a packet, right? This is a packet with a source and destination MAC address added to it. So we're just going to call that the frame header. That's not very legible, but that says frame header right there. Okay, but also what is known as a trailer. So when you see this, you no longer have a packet, but is now what is known as a frame. It's a completed frame at this point. Once it's got that frame header and the trailer, the CRC, that is now a completed frame. The CRC is for the purposes of error checking a frame. So when it gets to the other end, it is able to check for errors within this frame. So once this is sent now on the network in the form of electronic impulses, that error checking code would be able to check and see if anything within this frame has become corrupted. Okay, so the process of adding IP address and MAC address headers to a chunk of data is known as encapsulation. So when you take data and you add an IP header, you've now encapsulated that into a packet. And then when you add a frame header and trailer, you've encapsulated it into a frame. Okay? So, and actually the reverse process is not known as decapsulation, as you might think if you were being logical, but it's actually de-encapsulation. So apparently whoever developed that name scheme was not an English major. So, but de-encapsulation is the reverse process of removing. Once it gets to its destination, the receiving device will actually remove the headers, right? Okay, And we'll discuss that in more detail and how those different addresses are used in more detail in later chapters. But that is the basic of creating packets and frames. So you need to understand those terms. You need to be familiar with those terms. I will be using them regularly, so I hope I will send out an email to make sure everybody is aware of this video, but I will be referencing oftentimes some of these video lectures. Okay, some additional terms. I mentioned I would get to the terms client and server, and those terms context. So each term is can be referring to three contexts, but the basic definition of a client is a workstation running a client OS specifically, or it can refer to the network software on a computer that requests network resources from a server. That is a more accurate description. The first one refers to one of the contexts, but client software can refer, so network software, if you remember back a couple of slides to the, I can go back and pull that up really quick. If you refer back to slide 29, let's see if I can jump back to slide 29 really quickly. If you refer back to slide 29, you see that there is network software on both ends. So either end could be the client, either end could be the server. Depends on the user application being referenced at the higher layer. So is the user application a web server? That would mean that the network software is going to be server network software rather than client network software. Okay? So client, the term client, quickly power through those. Alright. Packet and frames, packets, frames, client servers. Okay, so the term client, the best context, I think the most accurate context, is referring to client software. But it can be used, of course, in three separate contexts. That would be a client operating system. This is an operating system that is not a server operating system, so those two would be contrasted with each other. That is installed on a workstation usually. So a less powerful device. So not as much RAM, not as much processing power, everything else. So client operating system would be one of the contexts that you use the term client in. Client computer would be, of course, the device whose primary role is to access or run user applications and access network resources. So a client computer would run a client operating system. Okay, and then of course client software can run on any device that is accessing or requesting network resources from server software on another computer. So client software and server software, those two are always working together in pretty much every context where you're accessing a resource on a network. So whether or not it is actually running on a client operating system or a client computer, that can vary. But client software, so for instance, let me give you a for instance here. Client software is like a web browser. Google Chrome, Mozilla Firefox, people have different preferences, things that they like to use. But Google Chrome, for instance, you can install that on Windows Server 2016. So Windows Server 2016 is, of course, one of the contexts for the word server, which we'll look at here, is a server operating system. Okay, so that server operating system can have client software running on it. So the web browser is client software. It accesses web servers, right? So you can have client software on a server operating system, and likewise, you can have server software on a client operating system. So you have to understand the sort of three contexts that are used. Quick definition: a computer becomes a server when software is installed on it that it provides a network service to client computers. So that's the key here. you need to understand the context used. So you will hear the term server used in a lot of different ways, a lot of different contexts, and you will hear the term client used in a lot of different ways in a lot of different contexts. The most accurate is referring to the network software. Okay, so people oftentimes wonder, inexperienced people who are asking me questions related to, I've done I do consulting currently, and I have done consulting in the past, and one of the biggest questions that I'm asked related to people's networks when they're wanting to know about their network. They might be ill-informed by previous IT people, or they're wondering just out of curiosity. They want to know, do we have a server? And the question is sort of, because of the context, I understand they're usually referring to a server computer running a server operating system, but that is lost on a lot of novices and a lot of people who are unfamiliar with the way those contexts are used. So my answer is usually going to be no, because they don't have a server-based network, which we're going to look at the two network models here in a minute, peer-to-peer and server-based or client-server. But the reality of this situation is they may have different computers running different server software, but they're not on a server-based network. So, and they might even have server computers that are running on their network, but they're still, and server computers running server operating system, and they're still not on a server-based network. So people tend to associate server to, I don't know, it gets misunderstood a lot by inexperienced or unaware users. I'm trying to be as nice as possible. I don't want to dog on anybody, because people just don't know, and that's why you take classes. That's why you learn. But so the context is key here. You need to understand that any device has the potential to be a server. Any device has the potential to be a client. And so we'll look at sort of the two network models and how the two are differentiated. But the most important thing is server software. It's what's responding to requests for network resources from client software. Okay? All right. Okay, so network models. There are two major network types that we're going to look at. Pretty much all networks, all local area networks, this is what we're talking about at this point, is local area networks fall into one of these two categories: peer-to-peer networks or server-based networks. So a network model defines how and where resources are shared and how access to these resources is regulated. So in a peer-to-peer network, basically this is going to be the most common for smaller small office, home office networks, otherwise known as SOHO. I use that term a lot. SOHO is a term that I will use regularly. It just means small office, home office. It's an acronym, actually. So SOHO networks generally are going to be peer-to-peer, meaning computers can function as clients and or servers based on the demands of resources from those devices. So you can set up, in Windows, they have Windows file and print sharing. So if you set that up on a peer-to-peer network, there is no central controller for that. There's no primary server that's dedicated to that necessarily, though you can, but there's no centralized control. That's the key here. No centralized control as to who has access to those resources. The control would be per user, per device. Everybody would be their own administrator. Everybody would be their own, would handle their own resources and how they want to share network resources and what resources they access. So that is a peer-to-peer network. And you can have administrators that run peer-to-peer networks. I've done it before. Usually once you start to expand beyond about 10 to 25, 10 is Microsoft's recommended, 25 is their required maximum. Once you have 25 users all accessing the same shares, you have to move to Windows Server in order for you to be able to access the shares. It's particularly file sharing. And then there's other reasons where you're sort of limited. Client operating systems are limited in their capability to run server software, so there's not as much server software for client operating systems, though there is some that you can install or configure. So server-based networks are sort of contrasted with this. There is a central controller. Certain computers take on specialized role and function mainly as servers. There's in smaller networks, there's usually there usually is one dedicated server. Once you start getting larger, you go to the corporate level. Things get very you can get excessive with it. Servers are capable of clustering, which is something we'll talk about later. But clustering in a nutshell is multiple devices acting as one device. This is where the term supercomputer comes from. It's really just a cluster of devices that are sharing their resources together sharing their processing resources together, meaning their CPU and RAM and everything else, and even storage to allow users to access those resources. So there's a couple of different types of clusters. We'll talk about that in more detail in later chapters, but actually in the second half of the class we'll discuss clusters and more details about servers. But you have central computers that take the role of servers, and they don't function for any other purpose. They don't jump down and become clients. Now, these terms can become sort of muddy when you're not clarifying them specifically, but let's sort of look. The peer-to-peer network, we talked about I've sort of mentioned each one of these things, but so each user must act as their own administrator, and that's one of the biggest drawbacks with a peer-to-peer workgroup model. Workgroup is a Windows term, by the way. So peer-to-peer is a general term that can be applied to Linux and Mac OS and everything else, but the workgroup model is sort of the Windows terminology. So, and that's contrasted with the domain model. So client, server, or domain, peer-to-peer or workgroup. But the workgroup, each user, each computer manages their own credentials as well. This would be how users access their own device, number one, and also how users access files shared or resources shared from that computer. So they would handle their own credentialing, usernames and passwords. Okay. And essentially any user can share resources on his or her computer with any other user to a limited degree, because in peer-to-peer networks there's usually no server operating systems. You're limited on the capability for how you can share resources and what extent that you can share resources. Okay, so some difficulties with peer-to-peer networks. You must remember multiple sets of credentials. If you're moving from device to device, you might have to know 2 or 3 different passwords and usernames in order to log into those devices. Now, you can alleviate some of these problems by different means. So there are some network administrators, myself included, that have set up peer-to-peer networks that function in a lot of ways similarly to client server networks, but it's more difficult. There's no central way to do it. You have to go to each device individually. And again, desktop PCs and their operating systems, so client computers and client operating systems aren't as efficient at providing network services, okay, as dedicated network servers. So network servers, server computers and server operating systems provide server software in a much more efficient manner. And then data organization. If every machine can be a server, how can users keep track of what information is stored on which machine? That can become a little bit muddy, a little bit convoluted. Having central resources becomes a must when networks grow, like I say, beyond about 25 users, because things start to get mixed up and lost, and data gets corrupted and moved and all kinds of stuff. So if a computer crashes that was hosting file shares and people were saving stuff to that, you can lose things. So that's a big drawback to peer-to-peer networks. So having a central server for data organization really does make things work a lot smoother. But that being said, the main I would say the main advantage is that peer-to-peer networks are good for small organizations with small operating budgets. So by default, when you first set up a network as of any size, SOHO specifically, small office, home office sized, until you add a central server and join each of those computers to that client server network or domain network, you have a work group. So by default, work groups are in place anytime you're using Windows, or peer-to-peer networks are in place anytime you're using a network without a central controller. Okay, and then the other model that I'd like to talk about is the server-based or domain-based model. So workgroup is contrasted with domain, and peer-to-peer is contrasted with client-server. Okay, so or server-based. So server-based allows centralized control over network resources. It means that you have dedicated computers dedicated to resource sharing. So and again, there's a number of different contexts in which the term server is used, but a domain controller is a specialized server used in domain-based networks. But users log in with a single set of credentials maintained by one or more servers running a server OS. You can do a lot with this. So you can allow certain users to log on to certain devices, but not other ones. It really does. Excuse me. It really does allow for a lot more control of resources, particularly credentials. Credentials are a big one. In most cases, servers are dedicated to running network services, and should not be used to run user applications. So when you're setting up server-based networks, you dedicate your servers to running server applications or network services, server network software, in other words, and not client software. So, or client applications. Okay. So some terminology here. A domain, the official definition, is a collection of users and computers whose accounts are managed by Windows servers. So domain, like I say, is a Windows term for a server-based network. The Windows servers that manage those accounts are known as domain controllers. Okay, so Windows server running a service known as Active Directory would be a domain controller. Okay, so another big benefit, I would say, of using a server-based model is that you gain the ability to control users and computers in a domain and subject them to a central security policy defined by the network administrator. So there's a greater amount of security that you can configure in a domain-based environment, where in a peer-to-peer network, each user would essentially be responsible for their own security and their own security policies locally. So even if you are a network administrator trying to not pull all your hair out in a peer-to-peer network, the security policies that you would set, or if you'd be interested in setting security policies, you'd have to do from device to device and change them per device. So rather than being able to do it from a central location, you have to go to the device and make your configuration changes. So that makes things a little bit more difficult as well. So The software that manages this security is referred to as a directive service or directory service, and I mentioned on Windows servers, the directory service software is called Active Directory. So if you have Active Directory installed on a Windows server, it is a domain controller. That directory service allows you to subject users and computers in your domain to security policies. So you create users, you change users. We're not going to delve into that in too much detail in this class. We'll look at server administration in a little bit of detail later on. But if you want more about this, we offer several classes at Yavapai College. CNT 120 is one of the classes that is highly valuable to that end. It's an introduction to Windows Server. So you begin by installing Active Directory and learning how to add users and play around with the domain. So, and then if you really want to delve in and understand Windows Server way more than the introductory course, we have 2 additional Windows Server courses, 122 and 123. So those are very good classes. I would highly recommend. I mean, many of you guys will be pursuing the degree, and those classes are mandatory for the degree program as it is today. So there may be some changes coming down the lines, but we'll discuss that at a different time. So there's some other network services that can be found on network services. Ooh, there's the bell. I'm at the high school right now, so that's why that's ringing. Wait for that to finish. All right, so other network services that can be found on network services or network servers. Naming services. These translate computer names to addresses. So we're not going to delve too much into that. Email services manage incoming and outgoing email. Again, we'll delve into that in more detail later. Application services grant client computers access to complex applications that run on the server. This would be things like databases and stuff like that. Communication services to allow remote access to a network. Things like a VPN, those terms might be familiar to some of you guys. We'll delve into all of these later. Web services, this would be for accessing a website. And those are all services that are offered by Windows Server in different varieties and types. We'll delve into these in more detail later on. Server-based networks are easier to expand than peer-to-peer networks. Peer-to-peer networks should be limited to 10 or fewer users. That is officially Microsoft's recommended. 25 is their maximum. As far as when you do file sharing on a peer-to-peer network, you can't have more than 25 users accessing a file share at the same time. So when you grow much beyond 25, it's really time to think about upgrading to a server-based network. Server-based network can also handle up to thousands of users. So when you start talking about domain-based or server-based networks, you can handle thousands of users. And multiple servers can be configured to work together. This is known as clustering. So to run more efficiently or provide fault tolerance, meaning if one goes down, you don't completely lose that resource. So fault tolerance is not about a backup. A lot of people confuse those two terms, but fault tolerance is more about providing for the possibility of a server going down and maintaining uptime. Okay, and then peer-to-peer and server-based networks both have advantages, so using a combination of the two models isn't totally uncommon. Okay. Alright, so you guys can look at that. That is sort of a breakdown of the comparison, resource access, security, performance, and cost. You will want to look through that for the purposes of your test, so you can find that in the modules. So I'm going to skip kind of through these questions. You guys get a quick look at some of the questions that are on the test. And that's it. That's it for me. This video is about 34 minutes, so I'm going to go ahead and sign off. thank you for checking this out. Hopefully if you made it this far, then more power to you. If not, I totally get it. It's kind of hard to sit through a lecture, no less a video lecture. So I encourage, I will send an email out related to this. I guess you guys will already know that at this point. But if you have made it this far, very good. I appreciate that. It's going to help you. I will reference these videos as we go through the class. So if you aren't watching them, you might miss some things because it is sort of a hybrid course. I only have 2 hours to complete these lectures, and I need just that little bit of extra time. So you see I finished the rest of this in 30 minutes. There's some that might be another hour. So normally I teach this class in 3.5 hours. So it adds to the difficulty level, but we'll try and get through it together. So, thank you.